Hey math kids, we're in section 10G and we're talking about dependent events, and we're just going to jump right into example 17. So it says a box contains 4 red, 2 yellow tickets. 2 tickets are randomly selected from the box, one by one, without replacement. So without replacement. Okay, find the probability that both are red. Okay, probability that both are red. So we're going to think of this, we're going to have 2 things multiplied together. So we're going to say this times this. So to draw a red the first time, there's a 4 out of 6 chance. But on the second draw, one of the reds is gone. So now there's going to be a 3 out of 5 chance. And we just multiply those together. We get 12 out of 30. And then we can divide both those by 6. So we get a 2 out of 5 chance for that to occur. Okay, the next thing we want to look at, the first is red, the second is yellow. So red, then yellow. Okay, so we had 4 red, 2 yellow to start off with. So probability of red on the first one, it's 4 out of 6. And then we don't have a red, but now we want a yellow. So there's 2 chances out of 5 to get the yellow. Multiply those together, we get 8 over 30. And then if we reduce that, we get 4 out of 15. Okay? Now we're going to move on to example 18. It says a hat contains 20 tickets. And they're just numbered 1 through 20. If 3 tickets are drawn from the hat without replacement, determine the probability that they are all prime numbers. Okay, so let's just write down the prime numbers that we have between 1 and 20. Alright, I think I got them. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So if 3 tickets are drawn from the hat without replacement, determine. So we're going to draw 3 tickets. And so I like to set it up just like this. So if we're talking about primes, we have 8 primes. And we have 12 non-primes. So that's essentially all we're worried about with this. And so on the first draw, we have an 8 in 20 chance of getting a prime. Now because we reduced this to a 7, on the next one, we have a 7, and our total also went down, so it's 7 out of 19. Okay, then we reduce down to 6, and so we have a 6 out of 18 chance. So all we need to do is multiply this together on a calculator. So we got 8 out of 20. Times by 7 out of 19. And then that's times by 6 out of 18. So remember, we have to go to 3 significant figures. So it's 0.0491. 0.0491. And that would be the probability of that situation. Now we're moving on to example 19. It says 2 boxes each contain 6 petunia plants. Okay, so we're going to have, let's just call it box A, box B, So we'll do something like this. Okay. Box A contains 2 plants with purple flowers. And 4 plants with white flowers. Okay, and then box B contains 5 purple. Oh, I drew that box wrong. I have 1 too many. So let's get rid of these. Okay, so what was that? 5 purple. 1, 2, 3, 4, 5, and 1 white. Okay, a box is selected by tossing a coin, and 1 plant is removed at random from it. Find the probability that the plant was taken from box A and has a white flower. Okay, so if we create a tree diagram, we have 1/2 chance on picking box A or box B. 50-50 chance. And then from there, we can go purple or white, purple or white. Now, if we're in box A, purple has a 2 out of 6 chance, and then 4 out of 6 for white. Purple for the box B is 5 out of 6, and white is 1 out of 6. Okay? And the question they ask, we want the probability that we're A and white. So probability of A is 1/2, and white would be 4/6. So it's 1/2 times 4/6. We multiply those together, and we get 4/12, which is going to give us 1/3. Okay, the next question says, has purple flowers? So basically just probability of purple. Okay. So what we're going to have to do is we're going to have to find the probability that we are in A and have purple, and then add it to the probability of B and have purple. So if we wrote that out, it'd be probability of A intersect purple plus probability of B intersect purple. So the probability of A and being purple is going to be 1/2 to get into A, and then purple would be 2/6. And then the probability of getting into B is 1/2. Probability of being purple in there is 5/6. Okay. And just do a little bit of math. So let's go down here. So that's going to be 2/12. This is going to be 5/12, which that is equal to 7/12. And we have one more example. So let's go to example 20.